Okay, so now we're going to sketch two periods of the sine function, right? Y equals sine of x. And we're going to do this in radians, and we're going to do this in degrees. We're going to sketch two periods, okay? So, once again, we know where this comes from for our ratios, right? If we start at 0 degrees, we know that our sine ratio is 0. We know that when we come around and make half of a revolution, we know at 180 degrees, the sine ratio is 0. We make another half revolution. We know that at 360 degrees, the sine ratio is 0. Okay? Now, we could have done this going backwards, right? And we know that every half a revolution, whichever direction I'm going, my sine ratio will be 0. So I could go backwards 180 degrees. Sine ratio is 0. Backwards another 180 degrees. The sine ratio is 0. Okay. Now let's pretend that for this one, every 2 tick marks was 1 unit, right? That every 2 tick marks was 1 unit. Well, we know that if I got to 90 degrees, right? If I got to 90 degrees, I would be at a maximum, and that maximum would be at 1. And if I was at 270 degrees, I'd be at a minimum, that'd be at negative 1. And the same thing if I went backwards, right? This is the shape that I'm going to have, so if I was coming this direction at 90 degrees, negative 90 degrees, I'd be at negative 1, right? If I went backwards, negative 1, and then at negative 270 degrees, I'd be at positive 1. And so I can kind of see that sinusoidal shape, that wave-like pattern. And I can come over here and try to draw a smooth wave-like curve, right? Don't want to have straight lines. Want to have these nice curved lines. Clearly see those values on the central axis. Clearly see those maximums and those minimums. The maximums and the minimums clearly evident. Very important that you label your axis. Okay? Let's do that in radians now. So here was degrees, radians. 0 radians, sine is 0. Right? Pi radians, sine is 0. 2 pi radians, the sine is 0. Right? We know every half a revolution, and there's 2 pi radians in 1 revolution. So every half a revolution, the sine is 0 because the y value is 0. Right? Going backwards, the same thing. Okay? Once again, if we let every 2 tick marks be 1 unit, every 2 tick marks be 1 unit for this one. Alright, at pi over 2, sine is a maximum. At 3 pi over 2, sine is a minimum. Negative, going in the backwards direction, negative. Right, negative. And we recognize what the pattern should look like. And we can come over here, right, and we say, okay, well, here is one period starting at 0. And if I kept on going on, right, I could continue that going in the other direction. And here I have, right, one period, right? It's hard to see, right, but we do distinctly have two different things here, right? Over here, working in radians on the right side, and over here, working in degrees. Okay. It's very important that we can draw that. So that was 2 periods. So let's go a little bit further with this. How do I determine the y-intercept, right? For the y-intercept, we're still going to let x be equal to 0. So therefore, the sine of 0, which is 0. Right? So the y-intercept is the point 0, 0. The origin is the y-intercept for the sine function. Okay. What about the x-intercepts of the sine of x? Well, the x-intercept still is going to be when y equals 0. So therefore, when the sine of x is equal to 0. So therefore, at x is equal to 0, and then plus or minus any number of half revolutions. Or at x equals 0 radians plus or minus half a revolution. And any number of half revolutions. Here we have the degree symbol because we're working in degrees. Half a revolution, 180 degrees. Here we're working in radians. Notice we have a pi, no degree symbol, right? At 0, the y value is 0. The sine ratio is 0 at 0. And then pi represents half a revolution and any number of half revolutions.